Hello, I'm Eric. I'm from SEP Group PG7. Today I'm gonna make a presentation of SDD review. The presentation will be divided into two parts. The first part is organization and completeness. We have labeled our charts and put them in explanatory text. In addition, in order to make design decisions documented clearly and motivated, we have documented the specific progress of a project and the software we use. It becomes the software architecture of the project. With the improvement of the project step by step, all the improvement measures of the architecture were also clearly recorded after each group meeting. For example, at first, we decided to use the A-star algorithm, but as the project progressed, we changed the algorithm to BFS because we found the situation of the map is unknown for the robot. We take notes of these decisions on the agendas and meetings. The design decisions are written on SDD, but the limitation for now of the algorithm are being tested and will be documented later. And the second part, software design. All the requirements of the project were clearly analyzed, documented, and covered in the design architecture. Every possible situation in the project is analyzed in detail, and a corresponding program solution is developed. For example, the UI can be divided into two modes, manual and automatic. In automatic mode, the robot may encounter different objects, black, blue, and white, representing boundaries, survivors, and accessible areas, respectively. When encountering these objects, the robot performs specific algorithm to accomplish different requirements. If the robot is stuck or an error occurs during operation, we can switch the manual mode to control the robot. We use modules embedded in Eclipse EV3 tool, which can realize the programming for EV3 robots. And for UI, we use Window Builder plugin. Furthermore, we prepare to design database to store map and user's account. On the other hand, we consider non-function requirements as well. For example, aesthetic and concise aspects of the UI. But at this stage, we have not considered an alternative code architecture, and the current phase is regularly improving and implementing the current code architecture. All of our group members have been allocated for a part of work. Additionally, for documented design methodology, we use the same class numbers and content in our programming compared with the document. And the basic function is also same with the definition in SDD. All designed Java class names are kept, and the input and output formats are set for subsequent development and maintenance of the code. For providing relevant architectural views, we use Finity State Machine to show the internal data and state of the system, describe the system's data flow and data communications, and created a system process diagram to show the processing scenarios which the robot encountered in various situations during the project. We also develop a physical data model based on the logical data model. For example, the getPost function that comes with the robot is based on the tail, circumference, and the counter. This is the logical data. We draw the map on the UI by abstracting the map into two-decimal Cartesian coordinate system. This is the physical data model. For flexibility of architecture, manual mode and auto mode of UI is in case of the error occurring. And we designed the UI login system and the port which links the IP address of the robot. That improves the user's security and provides the possibility to link multiple robots. Design entities result from a decomposition of the software system requirements. Each design entity will have a name, purpose, and function. There are common relationships among entities such as interface and shared data. The common character. According to the client requirement, we designed pathfinding, survivor identification, and positioning, avoiding obstacles, mapping these entities, and there are procedures under each entity, such as parking obstacles, rotating, transmitting coordinators. We use WBS and Gantt chart to monitor the project, improve technical issues through regular client meetings and group meetings. In addition, the person in charge will regularly review and provide advices for our work.